All right, one of the other basic ideas we got in Unit 4 is that a whole circle always equals 360 degrees. Central angles, in other words, angles with the vertex at the center of the circle, are equal to the arc, and inscribed angles, like this angle right here, where the vertex is on the edge of the circle. So this is inscribed. Inscribed angles are 1/2 of the arc. They are half as big. You can imagine if you drew the central angle here for the same arc, the central angle is twice as big as this inscribed angle. All right, so we know that this arc for number 10, by the way, in this video, I'm going to be looking at number 10, 11, 15, and 16 on the second page of the review. So we know that the entire arc is 13x minus 9, and we know that the inscribed angle, which is half of this, is 80. So we're just going to write that as an equation. Inscribed angle is 80. That's equal to 1/2 of the arc. Generally, whenever you have one of these equations, there are a lot of them in this unit that have the 1/2. The easiest way to get rid of that is just multiply both sides of the equation by 2. So I'm going to multiply by 2 over here. I'm going to multiply by 2 over here. That 1/2 and the 2 will cancel. So I've got 2 times 80 is 160 equals 13x minus 9. I'm going to add 9 to both sides. I get 169 equals 13x, and I just need to divide by 13. In this case, 169 is actually 13 squared. So 169 divided by 13 gives me x equals 13. All right, let's see if we can apply that. These concepts, whole circle equals 360, central angle equals the arc it creates, and the inscribed angle equals half of that arc measure. We'll use that in a few other problems. So next one is number 11. All right, this one looks a little different, but we do know some things here. We know that this angle here is 52 degrees, and it's an arc. It's a central angle because the vertex is here at the center of the circle. This is central. So what that means is it has to be equal to the arc. So this arc is 52 degrees. But we also have this chord is congruent to this one over here. And we know from the first video in this series that if two chords are congruent, their arcs are also congruent. So this little arc here is 52 degrees. Well, I just want to get x. X is the only piece of the circle I don't know. I know that x plus 52 plus 142 plus 52 has to equal 360. So all of this has to equal 360. So what I'm going to do is I'm going to add up the parts I do know and then just subtract from 360. So I've got 142, 52, and another 52. I'm going to add those up. That's 246 degrees accounted for with these three arcs. So x is just 360 minus 246, which is going to give me 114. I did that right? Yep, 114 degrees. All right. So the pictures are going to look different, but we've got these three basic ideas that we're just going to keep coming back to. Whole circle equals 360, central angles equal the arc, and inscribed angles equal half of the arc. Let's look down at 15 and 16. So number 15, this is a complicated picture again, but we do notice we have a line segment here from the center of the circle to the edge of the circle with a right angle. Now, if this is a right angle, this is also a right angle. So we have some symmetry going on. And in fact, these two little arcs are going to be congruent because this section of the circle and this section of the circle are just reflections of each other. And actually that's what we're looking for, is measure of arc LI. So I'm going to call that X. This arc here is X, which means this one is also X. Okay, I know this is 23. I know this is 55. Now let's think about how much is this. Well, here's the thing. Line segment GH is a diameter of that circle. It is going through the center of the circle, which means this is exactly half the circle. This is a semicircle right here. And this arc is half of a circle. 1/2 of 360 equals 180 degrees. So this arc is 180. So if I look at the whole circle, I have X plus 55 plus 180 plus 23. And that has to equal 360. This gives me 2x. I'm going to add up what I have. So 55, 180, and 23. If I add those up, that's 8, that's 15, that's 258. So 2x plus 258 equals 360. I need to subtract that 258. And I get 2x equals 102. Divide both sides by 2, and I get that x equals 51 degrees. You can always double check it by taking 51 plus 51 plus 55 plus 180 plus 23 and just making sure that you do get a full circle. So let's try that. 51 for x plus another 51 for the other x plus 55 plus 180 plus 23. Hope this works. Yep, 360. So that's it. That's all you're doing. Sorry about that. All right, one last one for this video. We have an inscribed triangle. Now, since the triangle is inscribed, each one of these angles is inscribed too. So there's a few different ways we can approach this. We do know that all angles in a triangle add up to 360, or I'm sorry, to 180. So we could use that to figure out this angle. That's absolutely no problem. We can also use each inscribed angle to figure out its arc. So this arc Z goes with the angle 65, and 65 is 1/2 of Z. So Z, just turning it around, multiplying both sides by 2, that's going to give you Z equals 135 degrees. Do the same thing to get Y. This inscribed angle, 60, is 1/2 of Y. Multiplying both sides by 2, we get Y equals 120. All right, so we have a circle. We have 3 parts to it. The part that was originally Z is now 135. The part that was originally Y is now 120. And we just want to figure out X. We know that the whole thing adds up to 360. So we're going to add up the 2 that we know. That gives me 255. And then we're just going to subtract from 360. And I get that X equals 105 degrees. So X equals 105, Y equals 120, and Z equals 135. All right.